Okay, and we are live. Welcome, everyone. Today we are hosting a webinar with an intriguing title on near infinite memory in AI. Well, why intriguing? Well, you'll learn soon as we're going through the topic that is super new at this point, and not everything is a state of the art yet. Let me first introduce ourselves. I'll start with our main webinar presenter, our Gen AI advocate, Bartosz. So at DS Stream, Bartosz is an expert in broadly saying artificial intelligence, AI operations. He's a DevOps specialist, certified developer, and someone passionate about solving problems by means of technology. And me, I'm supporting the stream in sales and product. Had opportunity to also work at AI-driven solutions recently. My role today is purely to make sure our webinar goes smoothly today, or at least as in the title, near smooth. Okay, so without further ado, Bartosz, the mic is yours.
Okay, thank you, Magda. So it's nice to be here. So let me share a little bit about our plan for today. So we are going to demystify this concept as near infinite memory. I'm going to explain how it works, how it doesn't. Our agenda looks like this. So we are going to briefly talk about this concept and promises that should be delivered in this year. Current state of a memory limitations and technical barriers. Of course, what actually succeed in 2025. So MCP is a very hot and interesting topic, and also agent-to-agent or A2A concept of communicating between two agents. Also, we are going to debunk why infinite memory didn't materialize and lessons learned. So what this happened that this concept is now not with us right now. So it might be in the future, it will emerge during this webinar, but why is not our presence right now, and also future potential and realistic timeline for this concept. So we are going to talk if this going to emerge in the future, we will see. Also, you are free to ask questions during the whole event. Of course, there will be dedicated session at the end to questions. But if you have something in your mind, feel free to reach us, because we are able to distinguish these questions from the others. So we can just answer during the event. But of course, there will be dedicated session at the end. Yeah, so I think without further addition, I think we can move further. So let me start with the first slide. What is near infinite memory? So the concept which is behind the whole event today. So basically, it means that this is the AI which is able to remember everything, all interactions that we have with this within our AI system. So this transition from zero start conversations to continuous relationship. So basically, AI which is able to remember the whole conversation that we had within the full history. So right now, I'm going to talk about this a little bit later, but let me explain this a little bit in more detailed way. So right now, if we are performing conversation with a model, regardless if it is a model from OpenAI or Google Gemini or any other LLM, we are limited by something which is called context window. So this context window means that we are unable to process information from the beginning of the discussion in the later part of the discussion, but instead we are limited within this box of context window. So near infinite memory means that AI will be able to remember the whole discussions, the whole history of discussion within this model from the history. So let's assume that we have a chat that we started with ChatGPT, let's say 2 years ago, because back then ChatGPT was present in our market. So let's assume that we just want to return to this conversation and we are not limited by this context window, and chat is able to remember everything. So yeah, that's basically this concept. Of course, it could have potential benefits, like having to be treated as potential personal assistant. So an assistant which is able to remember every single conversation that we had with them. So conversation that we started, as I mentioned, 2 years ago, and for example, we want to revoke some things from the memory, and without any hesitation, the chat will be able to answer this question. So that's the whole idea behind this concept. And let's talk a little bit about the current state, so current AI memory limitations, because As it will emerge during our webinar, this near infinite memory is not right now with us yet. So this concept is not present, because right now we are struggling with memory limitations from AI models. So context window, the concept that I described earlier. So let's imagine this as a kind of box that I mentioned. So whenever we are performing conversation with AI model, we are pushing this context window, this box a little bit down. So discussion that we started previously get rid of this, are not part of this box anymore, because whenever the new information appears to this box, the older information should be removed, should be pushed down from this context window, from this box, for the new information to appear. So that's the context window. Of course, in the current state as 2025, I think we are well developed in this manner, because companies like Google and models like Google Gemini are providing context window of even millions of tokens. So tokens as part of words or part of just single letters from the alphabet. We have a very large context, but still it's not the same as infinite memory. So still this context window is presented. Still we have this box, this limitation, even though the context is pretty large right now. Of course, the second issue is no memory between sessions. We have some kind of workarounds for them, like ChatGPT is offering something like memory, which is able to remember previous conversations, and it's able to reach to the different conversation to fetch something from this. But it's not the same as infinite memory. It does not mean that this chatbot has a possibility to fetch for older conversations, regardless of the date from the history. And also we have two types of memory. So parametric memory. So parametric means that this is the memory that any particular AI model gained during the training process. So of course, this process of training for LLMs, it's very extensive and very enormous in terms of computer power. So this parametric means that this is the memory that those chatbots gained during the training process. Of course, it has some limitations, and also retraining of the model is very expensive as a process. So it's not going to be easily repeated because of the costs, for example. And also working memory, it's like the memory that I mentioned. So this context window. So our let's say current present chat with ChatGPT, let's say, it has this limitation about working memory. So those two types: parametric as a memory which model gained during the training process, and working memory as a memory which is present in our context within a chat.
Bartosz, may I have a question then to you to that?
Yeah, sure.
Regarding the current memory-related solutions. So in the recent projects you've done so far, have you noticed the real business case where infinite memory could have made a huge difference for you?
Yeah, I think so. I think in the project related to creating personal assistant, that will be the case. Because, for example, let's say that we treat chat as a personal assistant. And for example, we started conversation with this chatbot, let's say 2 years ago. I think the 2 years is a good time period. And for example, we can revoke something from our memory that we asked ChatGPT 2 years ago, but we are not 100% sure what was the response from the chat. So the assistant, which has this capability of the presence of infinite memory, that will be very helpful, because then we can allow this chat to revoke this thing from the memory and push it back to us. So I think that will be the case, because I used to work on something like personal assistant. So that will be very helpful. Of course, other examples, we will tackle this next. So we'll be talking about the different examples, but I think this one it's useful, because I think a lot of people are treating these chatbots as a personal assistant, and I think it's a commonly spread use case for chatbots and for LLMs in general. Yeah. So yeah, the next slide, the big promises from late 2024. And as you can see on the screen, we have Mustafa Suleyman, so CEO of Microsoft AI. And he said back then that AI will have infinite memory by 2025. Of course, it did not happen, unfortunately. It was like a big promise from Microsoft, because behind this, it was not only words, because he also mentioned the paper which Microsoft created about this concept of near infinite memory. So of course, it was not a white paper, so not a concept which emerged and it's like treated as official concept, but still kind of technical document about this concept of infinite memory. Also, he said that Microsoft used to work on some kind of prototypes of this. So we can think that if such company as Microsoft is saying that they are working on prototypes and they promising something, it should be delivered. But for some reason, it did not happen. Also, Google has some kind of shares in this market as well, because they published also something like white paper called Infinite Attention. Of course, it was behind this company, so such a big company as Google. So it was very loud spoken during in the whole AI industry back then. And of course, it started this media buzz, let's say, about AI revolution, because whenever such big company announces something like a new concept like this infinite memory, of course, it starts kind of media buzz about a new revolution, new way of thinking, and etc. So it started a lot of discussions about this concept. Moving next. What's actually delivered as an opposite of near infinite memory, which was not delivered? So what's actually delivered in 2025? So the first thing which comes to our mind, for sure, it will be AI agents boom, because we can see a big increase. So 70% of companies implementing this strategy, this AI agent technology in the present year. Additionally, as MCP as a standard, so we have more than 2,000 servers. Of course, we are going to talk a little bit next about this concept. And agent-to-agent communication. So maybe to describe it a little bit, AI agent is, of course, we have just to mention, we had two separated sessions about AI agents, so feel free to watch these recordings. But in a way, AI agent is a kind of concept about autonomous AI solutions, so AI which is able to perform certain actions without human intervention. MCP, as I mentioned, I'll talk a little bit later, but we can treat MCP as a standard of communicating a particular tool to AI. So like a USB wire for between AI and a particular tool that we are using, let's say, on our IT systems. And agent-to-agent as a kind of infrastructure which is able to connect two agents to each other. Of course, I'm going to talk a little bit more about this concept later. So that happened, and we can see implementations of either MCP and agent-to-agent, but not near infinite memory. So we can we can set a question: why infinite memory didn't happen? What is the reason behind this? So we have some factors which are present here. So proactive interference as a fundamental limitation. So it's related to the whole infrastructure behind large language models. As you can see on the screen, we are presenting transformer architecture. So in a nutshell, it's very simple because we have an input, then the input goes to embeddings, it's decoded, and then we have an output. So this infrastructure, in reality, is very simple. So it's a simple architecture. And when we want to implement something like infinite memory to this, it's going to be a little bit complicated because we should think about modifying this infrastructure, because transformer, it's dedicated to performing text inputs as a chunks, not a whole, not like a whole text, whole page of a text, rather than as a chunk made out of element of this page. So it's a totally different approach. So we should think about modifying this transformer architecture to be able to process larger inputs. So that's the first factor. Cost and privacy concern. Of course, as we probably all of us know that either way, transformers and large language models are very not cost effective, are very power consuming tools. So saying about transformers, as I mentioned, we are processing smaller chunks of text. But let's imagine what will happen in terms of compute power or just even memory when we are going to talk a little bit about processing a larger part of text. So that will consume a lot of compute power and take more and more memory. So that's the second factor. And yeah, transformer architecture, as I mentioned, requires new solutions. So this proactive inference and transformer architecture are connected to each other, because transformer, as I mentioned, it's about processing information in chunks. And also, as a result, we have this context window. So we need to figure it out, a new way to process information, maybe Transformer 2.0 or something like that, to implement such solution as near infinite memory. So those three factors are the most important ones among others. Yeah, the future potential of near infinite memory, because Magda asked me about the implementation and I answered with the such case like a personal assistant. So I think all of those cases which are described here are similar to each other. So in terms of healthcare, let's imagine that we are chatting with a chatbot and we have memory saved for like, I don't know, maybe memory from 5 years back then. And this chatbot will be able, with this concept of infinite memory, to fetch information back then, and for example, to remember that we asked either doctor or a chatbot about some certain issue that we are struggling with back then, let's say 5 years ago, and the chatbot is able to revoke this information and transition it and compare to our current health state. So that will emerge a new possibilities to treat patients better and also to improve healthcare in general. So I think that will have good benefits. In education, just about everything comes in terms of education and large language models. I think everything comes into personalization. So we can personalize those tools even better than we have right now. So personalization through years of progress. So this chatbot will be able to see our progress year by year, or even decade by decade. If we are talking about infinite, it means literally means infinite. So maybe decade by decade even, and that will make the whole new experience about learning something new. And customer service, I think it's the example is obvious here. Let's say that we want to connect to, let's say, communication provider, and we are struggling with some issue with our either smartphone or with internet connection. And on one day we are talking with consultant A, but on the other day we are reconnecting to the customer service, and we are redirected to the customer service B. And it's problematic because we need to explain our issue once again from scratch. So it's problematic and a very mundane task. So instead of this, we can connect with one, let's say, AI assistant with this concept of infinite memory. And this assistant will be able to remember everything from our previous discussion, and also the issue that we described just the day before. So I think that's very useful, and it's a very practical case for such implementation. Okay, so the next question, where are we now in terms of this concept? Of course, right now we have larger context windows that we used to have, let's say, two or even 3 years ago. Yeah, because 3 years ago the chat was not present for the audience, but some models from OpenAI were present. So those chatbots were more limited in terms of context window, because we had like 32,000 or something like that. Right now, Google is offering even 2 million context windows. So the progress was made, and all of those companies are working, like OpenAI, Anthropic, and Google are working to still improve the context window to better address issues from the users. We have also RAG, so retrieval augmented generation, as a temporary workaround. So we can think about RAG as a kind of filter for the information for the model. So if model is not able to reach their context, their memory to ask our question, then it's able to reach to our documents that we uploaded, for example, before, and treat those documents as a way of learning new things. So this is rather workaround, not an implementation of near infinite memory. So it basically means that this AI model has no better memory, rather than it has an access to, let's say, library of information. So library, which does not mean that this information is stored in the model. It's like a new way of gathering information. And also focus was shifted to other trends, as I mentioned. So we saw two implementations, so MCP and agent to agent, or AI agents in general. So whenever there is a situation that someone is promising something, but this thing is not delivered, and at the same time, like the concept of MCP or agent to agent, it's delivered, the focus is shifted to things, to think more tangible, to the thing that developers can start to work with. And that's the reason that no one is right now talking about this concept, because we can just see the real implementations of either MCP or agent to agent, because those things emerged in reality instead of near infinite memory. Yeah, so conclusions, which we can take from this technology more complex than expected. It emerged that infinite memory it's to be more complicated than probably a lot of people were thinking about. Not every hype becomes instant reality, so I think it's self-explanatory. So, as I mentioned, MCP or agent-to-agent became a reality, so people started to develop things around that, and near infinite memory didn't, so we cannot implement something related to that. And huge potential, but implementation delayed for reasons that I mentioned. So yeah, it's our current state as 2025.
So Bartosz, where
So
are we?
yeah.
Sorry, so where are we heading right now with this whole AI concept? What can get to the mainstream?
Yeah, I think that's those the things that I described a little bit, but I'm going to express it more during the next slide. So the first thing, like you, Magda asked, MCP, the success story, because regardless the fact that near infinite memory it's not part of our daily life right now, we have two success stories, or even three if we think about it. So the first thing is MCP. As an example of success story from last year. So it was announced by Anthropic in November 2024. So around the same time when near infinite memory was promised by Microsoft. So it was similar in terms of in the matter of time. So as I mentioned, it's a like standardized way of for AI models to connect to data sources. So like a USB-C or USB cable just for AI. So we can, as you can see on the screen, so let's say we have an API from Gmail, an API from Google Calendar. We can use MCP as a connector, and we can connect via MCP to our AI model. So it has unlimited potential because we can connect almost everything to our AI systems. And indeed, right now we have more than 2,000 community built-in MCPs by mid 2025. So it's a pretty new technology because it emerged like a couple of months ago. But still, we have more than 1,000 examples of such implementation. It is going to be bigger and bigger. So that's the first success story. And also, we have another one, which I described a little bit earlier. So agent to agent as a new standard of communication between agents. So MCP is a concept which allows us, or standard which allows us to connect and not AI thing to AI model via this protocol of MCP. But agent to agent is a different approach. So it's like purely for agentic workflows. So let's say we have two agents talking to each other. We can use agent to agent protocol to establish some kind of connectivity between the two. So have my agent call your agent becomes real. And probably a lot of people were able to see this movie, which is very popular on YouTube, about agent to agent in practice. So two agents were talking to each other and they were using language which is foreign to human beings. So yeah, they established a new language to communicate to each other. So we can see a lot of examples as well, like MCP in the real implementation. And of course, this cross-platform agent orchestration, it's going to be bigger and bigger as well, because let's assume that we have one set of agents created with, let's say on Google Cloud, and another one which was created on Azure or by any other provider. So this protocol agent to agent allows us to connect even such types of agents because it works regardless of the technology behind. So let's say one set of agent it's on one cloud provider, second one it's built with different technology, but this protocol allows us to connect those two to each other. So yeah, it works great because we are not should not be strict to particular technology which stays behind a particular agent implementation. So yeah, expertise adoption faster than expected because, as I mentioned, that was the factor which states for success story for those two solutions, because it emerged, it was promised, but also it was delivered, and developers were able to start to work on this. Yeah, and that made the whole idea about creating a new integrations, like 2,000 examples of MCPs and probably enormous and countless number of agent-to-agent implementations. Yeah, moving forward, why this succeeded while infinite memory didn't? I think we tackled this a little bit earlier, but let's express more about this. So MCP solved immediate integration problems because it was a problem from the beginning of presence of LLM. So how to connect my LLM to my, let's say, local application or API, which is not agentic or which is not able to connect to AI without any intervention. So it's basically answered this question and allowed developers to start working on a practical implementation. And also, agent to agent, as another success story that I described, it's built on top of existing agent frameworks. Because when we are talking about near infinite memory, as I mentioned, we are limited by this transformer architecture. It's difficult. It's going to be difficult to build something interesting in terms of giving large language models infinite memory using existing technology, because transformer architecture, it's in a nutshell, it's simple and it has its limitations. So that's the first factor. But in the opposite, agent to agent is built on top of this infrastructure. So you don't need to reinvent the wheel once again. You can just take the advantage of the existing technology, existing standards, and to build something on top of this. So yeah, I think that was the most important factors. So in reality, just to summarize this a little bit, practical versus revolutionary approaches, I think in this manner, practical approach will always win, because when we are talking about something practical, it means that the community can start to work on this, can build something interesting, can start to integrate something to each other. But if we are talking about implementations, further plans, potential, of course, it's like a promise, but it's not delivered. So it's going to be difficult to build something interesting on top of this. Yeah. And then the pattern, what makes AI trend stick? So immediate practical value. I think the examples were just were obvious for you right now. So MCP and agent to agent, it has practical value. Building on existing infrastructure. So transformer architecture is pretty old because it has like 8 years. It's like I think 8 years old. So it's not new. But as you can see, we are 8 years from the development of transformer architecture, and still we don't have anything new in this manner. So still, all of those tools are built on the infrastructure which was created 8 years ago, by Google. So this famous white paper, attention is all you need. Clear return on investment for businesses. I think it's also important, because these tools are answering like tools like MCP or agent to agent by answering the questions and problems that were not addressed before, are also able and more likely to be adapted by businesses, because we can see clearly the return on investment with these tools. And for near infinite memory, we don't have this vision, like return on investment for such protocol, such implementation. And community adoption and development, because, as I mentioned, in terms of either MCP or agent to agent, it's clear that within this implementation, the developers started to work on these tools and these protocols. We have implementations in real world scenarios, also other integrations, but the whole community was built around it. So there is a separated community behind which stays behind agents, separated community for MCP, separated for agent to agent. And behind this, there are countless examples of such implementations. So developers are creating tutorials, new courses. There is a totally new market around this. So this adoption allows everyone to just gain something from this, instead of just promise which was presented but it's not delivered. So I think that's the case here. So lessons for AI development. So incremental improvements often beat revolutionary promises. So whenever something is delivered, it's it's always better than something which is promised but it's not delivered yet. Developer ecosystem adoption is crucial. So developers don't want to hesitate on starting to work on something. If they had to pick one thing among MCP and agent to agent or near infinite memory, it's easier to start to work on real implementation, because we can see example, because the protocols were established, so we can start to build something around this. But it's not going to happen with near infinite memory because we cannot see implementation. It's like a promise, but we don't have any implementation yet, in terms of real development, either development toolkits or some libraries or anything like that. So market readiness versus technical possibility, and as also an important factor, because as I mentioned, MCP was able to address the question and answer the questions that people used to have back then about connecting different AI tools, and that allowed the market to assemble these connections and make a transition from a case to the real example and real implementation. And of course, it's very interesting to talk about technical possibilities like new concepts, quantum computers, near infinite memory. But it's just a pure talk. But for technical people, the whole implementation, rather than talk, it's more interesting. And I think in majority of cases. So it's also connected to hype cycles versus implementation reality. So there is a lot of hype already in terms of AI. I think we are going to see more and more in the near future. But for technical people, still implementation is better than just pure talk about something which is maybe going to happen, but we are not sure if it's a case.
Yeah, super interesting. So then we should keep the fingers crossed for the infinite memory. Okay, thank you, Bartosz, so much for this interesting webinar for us. We don't want to leave you without, with your bare hands. So we have an ebook for you. You can scan the code, and then you can download the ebook on the implementation of the AI in your organization. But we are heading towards the questions here right now. Don't worry if you can scan the code right now. We will be displaying it also at the end of this webinar stream. As waiting for the questions, maybe we should say a few words about the company that allowed us to be with you today. DS Stream. So we are a consulting company, and as you probably noticed, thanks for this webinar, we are mainly focused on the artificial intelligence, machine learning, MLOps, data science, and all of that topics that are super interesting right now on the market. And we are working with the big brands. So we are the company with over 150 engineers right now, over 7 years on the market, everyone certified in some area of software development, cloud providers, and we work mainly with the companies within the retail, FMCG, healthcare, and more. So if you want to learn more about the company, please follow our website or our site on the LinkedIn, actually, and you also won't miss upcoming webinars. Okay, let's wait for some questions here from the audience. Okay, let me read the first one maybe. MCP and agent-to-agent worked, near infinite memory didn't. Can you think of other AI technologies that were hyped but took longer to deliver than expected?
I think it's interesting one. So the first thing which comes into my mind is an example. I think it's partially connected to AI, but still, I think a little bit it is. It's about this quantum computer from Google. I think it was like 3 months ago about Willow, a new quantum computer from Google. And also, it was like a promise that this new quantum computer will be used for training process for AI models. But it's turned out that it's a real computer, but it has similar limitations like other ordinary quantum computers have. So I think that's the thing, which is like one of the most recent examples of such a thing. Of course, I think quantum computers in general could have a great impact on AI development because of their infrastructure. But still, I think it's a kind of similar concept to near infinite memory. So we have a little bit progress, like in terms of memory, those bigger context windows, but still, it's not the same as saying that we have unlimited memory or we have, let's say, no barriers between quantum computers and process of training AI models.
Okay. Okay, another question. Yes, we saw that 70%, yes, you mentioned that number during your webinar. 70% of the companies are implementing AI agents in 2025. Do you see AI agents being used in your organization, and for what tasks?
Yeah, I think it's interesting because we're just starting the implementation of agentic workflows for organizations. So we just want to automate some processes like internal things like recruitment processes and etc. So the possibilities are just limitless. So we are just thinking right now about new workflows which could be automated. But yeah, in general, the answer is yes. We can see the implementation. We just start to real implementing something in the company, because as an AI company we can see the potential. So there is no way, there is no other choice than not to automate something which is part of our organization as well, because we are just an AI company. So yeah, this AI workflows will also emerge in our company as well, and we can see this progress, this trend of progress for AI development in our case as well.
Okay. Do you have any? Do we have any more? I don't see more questions. So if you want, you can also leave the questions for us on the section of comments on LinkedIn or YouTube under this stream that is also streamed there on YouTube for you. And yeah, so thank you, Bartosz, and see you till the next webinar.
Thank you, Magda. It was
Thank
nice
you.
to be here with you, and thank you everyone for joining.
Yeah, till the next one.